Chapter 4 Effects of the Electric Light upon Vegetation. It is well known that if a plant be kept in a dark place, it will lose its green color and pine away. Experimenting with plants deprived of sunlight, Professor C.W. Simons found that if he substituted the light furnished by electricity, the plants would keep in a large measure their green color and grow almost as vigorously as with the sun shining upon them. Recently, a gardener without any scientific ability and without even the intention of experimenting arrived at a similar conclusion. He was extremely puzzled one day to find that some lettuce plants at one end of the greenhouse were far in advance of those of the same age and variety at the other end. He was finally led to conclude that an arc electric lamp, which had been burning every night at the prolific end of the lettuce bed, was the cause of his good fortune. And further experimentation proved this conclusion to be correct. The arc electric lamp furnished a light very similar to sunlight, being however somewhat richer in the rays beyond the violet and slightly deficient in the orange rays. The use of an orange-colored globe makes it more nearly like sunlight and favors its action upon vegetation. The naked arc light, if too near some plants, exerts a detrimental action upon them, and one must carefully study the susceptibility of the individual plant in order to regulate the distance between it and the light. The length of time the lamp is kept burning and the color of the shade through which the light is permitted to pass are also matters of importance. The value of interposing glass between the light and the plants has been demonstrated frequently. For instance, Dr. Bailey of Cornell, whose work in electro-horticulture has been of the highest order, found that radishes under the naked light lost from 45% to 65%. Under a light covered by an opal globe, the loss was but slight, while when the light was strained through the opal globe and the glass roof of the glass house, there was an increase in both tubers and tops. He obtained similar results with beets and spinach. Cauliflowers were so influenced by the light as to grow tall and extend their leaves in a vertical direction, but they did not head so well as those grown without the light. Tulips and petunias grew taller and more slender, had richer hues, and bloomed earlier and more freely. Lettuce was from 10 to 12 days earlier, and felt the influence of the light all over the greenhouse, which extended 40 feet from the lamp. Another experimenter tells us that a 2,000 candle power arc lamp will markedly influence a bed of lettuce 60 feet square. Simons found that the electric light was efficacious in producing chlorophyll in the leaves of plants, and that it promoted the growth of the whole plant and also hastened the development of flowers and fruits, giving to the former more intense coloring and to the latter finer flavor. In strawberries, the rich red color and fine flavor were especially noticeable, and the berries were brought to ripeness 2 weeks before their usual time. Melons also were quite responsive to the light and were much improved in aroma. In experimenting with the electric light, one will find it very interesting to study its effect upon plants at different distances, as well as the effects of different transparent substances placed between it and the plants. Some plants are apparently scorched by the light, even if not near enough to feel the effects of its heat. The ultraviolet rays, which seem to cause this, are largely absorbed by plain glass. When a part of a plant is shielded from the light by a piece of ordinary glass, one may sometimes see a distinct line of demarcations between the plants so protected and that exposed to the glare of the light, Even a single leaf may be partly scorched and partly of an intenser grain as a result of its position in this respect. One must find the length of time each plant prefers the light to profit most by its influence, in addition to ascertaining its preference for intensity and for the color of the glass surrounding it. Plants seem to have an individuality and often show a decided liking for certain regulations in the use of the light in order to do their best when subjected to its influence. One would think that plants need the darkness for their well-being, just as animals require the night for sleep and refreshment, but this has been declared by a prominent investigator not to be the case, or at least but to a very limited extent. Under the stimulus of the electric light, they keep on growing at night almost as thriftily as in the daylight. What to us would be dissipation and end in disease seems to them to be profitable pleasure, if the light is properly regulated. Mr. B.F. Thwaite tells us that the leaves of that beautiful plant, the Acacia copanta, which close at night, open almost magically when removed from the darkness into the brilliant beams of an arc lamp, the leaves nearest the root being the first to be influenced. We have been alluding to the effects of the steadily shining arc light upon vegetation, but if it is flashed at short intervals upon plants, it seems to have increased power. At least it will draw the plants more rapidly and strongly towards itself. They seem to be whipped up, as it were, by the violent alternations of intense light and darkness. Heliotropism is the name given to this effect. It deserves a fuller investigation. It is not unlikely that in future experiments, devices will be used to graphically record the progress of the growth of plants. By using the methods of Mach, one may see plants grow and be able to follow them in some of their transformations. This process consists first in photographing growing plants at suitable intervals, and secondly, by means of a somewhat complicated apparatus, in passing rapidly before the eye the photographs of the plant in their various stages of growth. Thus, in a space counted by seconds, we may have passed before our wondering eyes the birth, developing, flowering, fruiting, and death of a plant. By reversing the order of the photographs, we are amazed to see the fruit evanescence into the flower contract into the bud absorb into the stem, and finally the stem disappear into the ground. By attaching a piece of fine platinum wire to a growing plant and fastening a small piece of crayon to the other end of the wire, it is said that we may have recorded on a rotating drum covered with white paper tracings showing its growth. If we cover the drum with narrow strips of platinum foil and connect them with one pole of a galvanic battery and the wire attached to the plant with the other, and then place the electric bell in the circuit, we will hear, as the drums rotate, the ringing of bells when the wire presses upon the foil, and have silence when the wire presses upon the spaces between the strips of foil. As plants are said to grow most rapidly between the hours of 4 and 6 in the morning, if we make the strip sufficiently narrow or have a rapidly growing plant, we will have the bell rung quite frequently at our waking hour.